The highlights of this video is I am taking ABB ACS 880 VFD drive for wiring it up to PLC, and when we are doing the wiring, what parameters do I need to change inside the VFD? Like this particular page is an example of how the different options are available on the VFD, and like just an example, like typically this XRO1 by default is ready to start, but I don't want to use like that. I want to use it XRO1 as a fault. So what do I need to change inside the VFD in terms of parameters? So that is something what we are going to focus in this video. So now in my case, I'm having a VFD connected to a motor, and in this motor I want to be able to run the motor in forward and reverse direction. So let's take an example that I want to run this motor in forward and reverse direction through a VFD commanded by a PLC. So I will have one forward command and one reverse command. So how do we do the wiring and the parameter change in the VFD is something that we are going to look into. Right now this is my the wiring diagram for this ACS 880 drive. So typically DI1 and DI2 is what we pick. DI1 is for start forward and DI2 is for start reverse, like start stop reverse. So how do I change that? First, how do I connect it? So what I will do is I'll take this 24 volt DC from the VFD itself as a power source, connect it to the PLC, and then connect it to XDI1, which will be my start forward command. The better way to look at it is this way. XDI1, I'm connecting 4 volt DC. When the PLC switch is closed, which will be a digital output from PLC, it will give 1 into this, or 24 volt DC into this one terminal block, which will be start forward, telling the VFD to start in forward direction. Same way, if I want to stop the motor, I have to just open this switch via PLC. So now I'm not getting any more this 24 volt DC into 1, so the VFD will stop. Now let's say if I want to run the VFD in reverse direction, the motor in reverse direction, I'll do the same thing. Just instead of closing the switch on 1, I'll close the switch on 2, so that the 24 volt DC is going into 2, which 24 volt DC is going into 2. So it will give a start reverse command to the VFD, and it will ask the drive or the motor to run in the reverse direction. Now this is more on the wiring part. We'll just look into what parameters we need to change on the VFD. So in 20.01 we will have external 1 command. In that we have to go in 1 is start forward, which is nothing but this in 1 as start forward, in 2 which is more like di2 or terminal 2 as a start reverse command. So just to see these parameters on actual, because I don't have a VFD, but somewhere close I can take you, is in the drive composer. In the drive composer, this is a, by the way, this is a very handy tool. It comes, it is free, and it comes with this search kind of option. So let's say we are looking for start command, start. So it will give me all the everything related to the start. So in this particular case we found like we want to change the parameter 20.01. so 20.01 is should have been over here. Let's try to see how it is. So let's see 20.01. okay, oh, it was external 1 command. So the default option here is in 1 start, in 2 is for direction. So instead of that we have to select this one, in 1 start forward, in 2 start reverse. So this, along with the wiring that we saw over here, will basically allow the PLC to dictate the start forward and start reverse of the motor. So now we will jump into this run feedback. How do we do the wiring for getting run feedback from this motor? So first we saw start forward / start reverse. Now we are going to see how we get a run feedback for this motor. How do we know that the motor is running? So in that particular case, let's look into the wiring diagram here. Typically the default for running is on XRO2, which is this terminal block number 22 and 23. Let's see how we will wire it up and see if we have to do any wiring changes. So let's go back over here, my handwritten thing that I've made. For run feedback, I'm going to connect the wire 24 volt DC as a supply going into XRO2 terminal number 22, and this is a NO contact. So if the drive is running, this will become closed and the 24 volt DC will come to 23, and 23 will be going into the PLC as digital input. So this is on the wiring side. Now let's see how we will do it on the parameter side. Now this may be already there because this is a default like 10.27 RO2 source running, but let's check that in the drive composer if that's the case. So let's see this 10.27. Yeah, so 10.27 we can see RO2 source is the running feedback, so we don't need to change, but just need to make sure that that's the case. Now we will jump into the next one, that is the fault feedback. Like we need a fault if the drive goes into a fault. So fault in this ACS 880 drive, typically the fault is on this one, XRO3. All the terminals starting with, starting as 30, 31, 32, 33 are belonging to XRO3. So this is faulted -1. I don't know the definition of faulted, but I have seen like when if the parameter is said for XRO3 is said as faulted -1, it doesn't give me a fault feedback. So I have to change the parameter, and the wiring is connected to more on 32 and 33. Let's see how it is connected. XRO3, so I'm giving the same 24 volt DC from the VFD itself, XD24 number 4 terminal 24 volt DC into 32, and when the drive goes into fault, this 24 volt DC, this switch gets closed, so I start getting 24 volt DC on 33. So 33 is getting 24 volt DC. This 33 then goes as a input to the PLC. So this is what it means. Let's check the parameter on the parameter side. Now in the drive composer, if we go to 10.30, so 10.30 is for RO3, XRO3 source fault. We need this as just fault, so that we get the fault on the PLC. So this is that parameter. Now let's say, so this is on the parameter side. Now let's say if we want to connect XRO1 to show me as a fault, so what do I need to do? So I just need to change. We can use XRO1 for showing me the fault. It can be done from the wiring side. It will be 24 volt DC going into coming out from this 4 XD24 terminal block 4, and it goes into number 12, which is for XRO1. I'll just show it over here. So number 12 is the common, and when the switch is closed, I'm getting a fault, let's say, then I get 24 volt DC going back to the PLC. Now this is going to happen only if I have the parameters changed to such that XRO1 switch will get closed for fault. If I have the parameter asking the VFD to do the same. So we'll just see the parameter number 10.24. It should be fault. So 10.24, if you look, I'm already in 10, and 10.24 is by default it's ready to run. I'm changing it to fault. So in case I want to use RO1, XRO1 as the fault, then this is the parameter I have to change. Now we will just jump into the next one, that is 4 to 20 milliamps. Now this is very interesting, and this is actually what made me make this video, because I had a lot of trouble in figuring this one out. So let's jump into this. What is difficult about this? Let me give you a little background. In the ACS880, there are two types of modes. One is DTC, direct torque control mode, and the other one is scalar mode. Now when we are in DTC mode understands only the speed. It doesn't understand the hertz. For now, just take it, because this is what kind of what I have learned. Scaler on the other hand understands only hertz. Okay, now why are we talking about the scaler and why are we talking about this hertz? What is the reason? Since we have installed a VFD, we wanted to control the motor speed or frequency. So how do we control that? We control that by giving 4 to 20 milliamps, in my case 4 to 20 milliamps to the PLC. So where do I connect this 4 to 20 milliamps to the VFD? I have two choices. I can connect it on, or I'll just won't make that a confusion. 4 to 20 milliamps or milliamp source for changing the speed or the hertz of the motor. I have to connect it on AI2 plus AI2 minus. When I'm doing that AI2 plus AI minus in ABB ACS880 drive, these AI2 plus is default configured to take milliamps. Now the default setting is 0 to 20 milliamps, so I have to change it to 4 to 20 milliamps. If, like in my case, I'm giving a PLC, PLC is going to give 4 to 20 milliamps. Okay, so that being the case, now I will now let's look at the wiring diagram for this, and I'll explain more about the DTC and scaler when we get into that. Now in this fourth number, like analog input 4 to 20 milliamps for changing the speed or the reference frequency of the motor. Now like I said, by default AI2 is milliamps. Now where do I see this AI2? Where the hell is this coming from? This is over here, AI2 plus in the XAI terminal block. Its terminal block number is AI2 plus AI2 minus. So it's 6 and 7. So 6 and 7 are connected to analog output of the PLC, which is giving 4 to 20 milliamps. Now you can see the default over here is 0 to 20 milliamps. So instead of that, I want 4 to 20 milliamps. So this 4 milliamps I have to put it in the parameter that I'll show later in the next step. But for now, once I am done with this, I do need to check a jumper setting. There is a jumper in the inside the VFD just next to, or I would say in between, XAI and XAO over here. Okay, so this should be jumper 2 is for AI2. It should be in current selection. Okay, now so that's for the wiring part to AI2. Now let's jump into the parameter part. The parameter part says if I am having the motor controlled in DTC mode, which is speed, I have to make sure that 99.4 is motor control mode is in DTC. So let us see that parameter 99.4. So 99, sorry, motor data 99.4 by default it is in DTC. So we just need to check that if we are in DTC mode. Now we have to make sure that AI2 unit selected is in milliamps. Where do I check that? I check that in parameter 12.25. So we'll check here 12.25. So 12.25 AI2 unit selection, this is by default in milliamps, so that's good. Now what next? 12.27, I have to make it, what I was telling you, that typically the default setting is 0 to 20 milliamps. So this is where we have to set this to 4 milliamps. So you can see 12.27, the default is 4 milliamps, sorry, default is 0 milliamps, so we have to make it 4 milliamps. Now 12.28, which is maximum milliamps, AI2 maximum milliamps. So 12.28 we will set it to 20 milliamps. This is default 20, so we don't have to change it, but just something we need to know or cross check. 12.29, it's AI2 scaled at AI2 minimum. What does this mean? If this motor is to run at 0 to 1440 RPM, so when I want to run this motor at 0 RPM, let's say I have to give it 4 milliamps. When I have to run this motor at 1440 RPM, I have to give it 20 milliamps. So I need to define this as AI2 minimum as 0, AI2 max, and this is actually AI2 scaled minimum, and this is AI2 scaled maximum. So AI2 scaled maximum is when I'm having 20 milliamps, 1440 RPM should be my maximum speed of the motor. So that is what I'm trying to say over here, that 12.30 will be AI2 scaled at AI2 max. That will be 1440 RPM, or whatever would be your motor RPM. Like let's say it's a 3000 RPM motor, then put it 3000. So this is what that mean, and it has to be changed over here. So in this particular case, let's say I have AI2 scaled at AI2 min as 0 RPM and AI2 scaled at AI2 max as let's say 1440 RPM. So that will be this. Now what about like now this is the real stuff now. We have to, where do we tell the VFD that what do you have to look at? Like it has two options. It can look into AI1 for controlling the speed, or it can look at AI2 for controlling the speed. How does VFD know? So we tell that to the VFD that look at AI2 by putting a parameter which is 22.11. So let's see 22.11. So 22.11 by default, if you see, it is speed reference 1 source. It says AI1 scaled. So look at the value of AI1 scaled. That's what we are telling the VFD. But in our case, since we have connected our 4 to 20 milliamps or the reference speed to AI2, so we change this to AI2 scaled. So this is something very important. Otherwise, It will keep on looking at AI1 scale and it won't run as we want. So this is something to be careful about. Now, so this is about VFD, where to look at for adjusting the speed. Okay. Now let's look at, like, why do we use the VFD? One thing is that we want to control the speed, like 4 to 20 milliamps. We want to control the speed of the motor from 4 to 20 milliamps. The other important thing is like how fast we want it to ramp up, like from 0 RPM to, let's say, 1440 RPM. How fast do we want to ramp it up? So that is something controlled by, so let's say this is plotting as y-axis as RPM and x-axis as time. So let's say, so this is like we want to ramp it up in something like 200 seconds. I'm using that, so I'll just put that. So 200 seconds. Why? How do I tell the VFD to ramp up in 200 seconds, not like within 60 seconds, or how do I tell that? So that's something we can say by a parameter again, and that is (21.3). First of all, let's get to this acceleration, since we wanted like to control how fast to ramp up or ramp down, how fast to ramp it up, since we are talking about that. So let's jump to the acceleration time. We are putting in 23.12 acceleration time 1 equal to 700 seconds. Now before we can put this parameter also first, but how does the VFD know, like this should be, it should be looking at this acceleration time 1 only? I want to introduce one more thing over here. In the VFD, like AI1 and AI2, there are two acceleration deceleration time. One is acceleration deceleration time 1. I honestly don't know why they have 2 times, but I'm just trying to make it simple. So, and then there is another thing called acceleration deceleration time 2. We have to tell the VFD that you look at this acceleration deceleration time 1 only. So which parameter do we do to tell that? And that is in the parameter 23.11. It's over here in 23.11 where we are telling the VFD to look at this acceleration deceleration time 1 and not look at whatever the other things are. The default is DI4, and there is other option like acceleration deceleration time 2. I don't know what they mean, but I know if I want to control a VFD to ramp up and ramp down slowly, then I have to give where to look for. So ramp set selection in 23.11, I have to put in 23.11 I have to put acceleration deceleration time 1, and then I can put acceleration time 1 as, let's say we were looking at 700 seconds, and deceleration time as 700 seconds. So I want to ramp up slowly at the speed in 700 seconds, and I want to ramp it down slowly in 700 seconds. Now for ramping down, I have to mention one more parameter, which is 21.3, that is stop mode by ramp. So stop the VFD with a ramp down rate, not a rate but ramp down, and for ramping down check out this deceleration time 1, that is 700 seconds. So I have to change this 21.3 so that when the VFD is stopping, it stops slowly. So 21.3, no, not this one, 21.3. so it's by default is coast. I have to change it to ramp down, or basically ramp. So these are the things I have to do. Again, this is applicable only if we are in DTC, like the motor control mode is DTC. What if the motor control mode is scalar? The wiring stays the same. We are not going to change the wiring. We are going to still connect 4 to 20 milliamps from the PLC to AI2 plus, AI2 minus. So the parameters for 12.25, 12.27, 12.28 will stay the same. Important thing we have to check is 99. If we are in scalar mode, one thing to keep in mind, in scalar mode, the VFD will be controlling the hertz and not the RPM. So we have to give the VFD, like in this particular case, we have to tell the VFD what is 4 milliamps and what is 20 milliamps. So if I have to, like, let's take another page. So if I have to tell this like 4 milliamps, 4 milliamps will be equal to 0 hertz and 20 milliamps will be equal to 50 hertz. So how do I tell that to the, like, how we have told over here in the parameters, that it will be from 0 to 1440 RPM. How do we tell that? So we will just go over here. First thing, we will check 99.4 is motor control mode is in scalar. So 99.4. So this we have to change it to scalar. Okay. Then we have to see 12.25 is in AI2, is for AI2 with milliamp selection. 12.25 12.25, this is by default milliamp selection, so it is milliamps. Now keep in mind all these things are the same, like 12.27, 12.28 are the same, like 4 to 20 milliamps. So 12.27 4 milliamps and 12.28 as 20 milliamps. The thing that is going to change here for scalar will be AI2 scaled at AI2 minimum, that is 4 milliamps, will be 0 hertz, that is over here 0. That is for 12.29 parameter. Now for maximum, AI2 scaled at AI2 max will be 50 hertz, and that will be under parameter 12.30. So this will be 50 hertz. Okay, so this is done. Now how will the drive or the VFD know, like, where it should look for, like AI1 or AI2 for controlling the frequency? Now note here, this is a frequency, whereas in DTC mode it was speed. Okay, so this is the difference between DTC and one of the difference between DTC and the scalar mode, that this should be 28.11 frequency reference source should be AI2 scaled. So this will be over here 28.11. 28.11 is like you can see it's 0 right now, so we have to give it AI2 scaled. So this will be something we have to change. Now same way, like we want to, why did we use the VFD? We want to control the ramp up and ramp down speed. Okay, so where do we do that control? So it is again acceleration deceleration time, but note that these are all in parameters 28, whereas in the DTC mode they were all in 21. So you know, it's different. For scalar it is different, for DTC it is different. So let's go into deceleration time. First, like I told you, like there are two acceleration deceleration time: acceleration deceleration time 1, acceleration deceleration time 2. So we have to tell the VFD that look at acceleration deceleration time 1, which is the default. So let us look at this 28.71. 28.71. Yeah, 28.71. So by default it is in frequency ramp set selection, which is acceleration deceleration time 1. Now we can give a acceleration time of, let's say, 700 seconds. We want the drive to deaccelerate the motor by 700 seconds. So 700 seconds here also, and we want to stop the motor by a ramp, like deceleration time. So we will make the parameter 21.3 as stop mode as ramp. So this is like, this doesn't change whether it is DTC or scalar. Okay, so this, you know, kind of covers the how, you know, 4 to 20 milliamps, if we want to control the speed of the motor by 4 to 20 milliamps, how we do in terms of parameter and how we do in terms of wiring. Now we'll jump into this Modbus communication. Many times, you know, on the VFD we have to monitor, let's say, what is the output frequency, or we want to control what is the output voltage, or we want to control what is the output current, or we want to check the, actually not control, actually I said the wrong word, control. We want to just monitor output torque. So rather than doing a hardwiring of there is of 4 to 20 milliamps or 0 to 10 volts, we have a provision in all the VFDs, even in ACS880, and it can be done just 1, 2, 3, 4 signals. We call it a soft signal through Modbus RTU. We just need to connect 2 cables and configure the VFD so that it sends these numbers to the PLC. So how do we do that? So we'll look into that. Now once we Modbus, how do we view this data? Like I said, output current, output voltage, output frequency, output torque. So how do we do the wiring? The wiring, we have to connect this XD2D 1 and 2 to the PLC. So let's look over here, 1 and 2 to the PLC. There is a jumper, like if you are making a daisy chain of multiple VFDs, the last VFD should have this termination switch on. So this is what that means. Now on the parameter side, I don't know, for some reason in the VFD, like drive composer, it doesn't have the parameter for the Modbus RTU. It just have one parameter, like 58.1. So we'll set this to Modbus RTU 58.1. The node address in this particular case 58.3, it's the parameter. It will be 2. 58.4 will be the baud rate, 19.2 kbps. This is, by the way, default in the VFDs I have seen. 58.5 parity will be 8 none 1, so it means 8 as the data bit, 1 stop bit, and I think none is for I don't remember, but anyway it's 8 none 1. And then 58.14 is communication loss action. It just should give a warning, it should not give a fault. So that is what that is. Now this is the important part. The VFD has to be configured so that it stores the data, like output frequency, into its holding register 40007. So PLC has to just read this holding register of this particular node address, and it will get the data of output frequency. So but this has to be configured in the VFD, that in 40,007 holding register store output frequency. So it is done by parameter 58.107. 58.108, it has to be configured to store, or it's one of the parameter that we are storing by this configuration into 40,008 is output current. Same way in 58.109, we are saving output torque into 40,009, and 58.110 we are saving output voltage in holding register 40,010. And any time we are changing any of this 58 parameter, it's better to just restart the VFD rather than because the settings don't reflect until you restart the VFD. So be careful, like you may not get the Modbus data, but you should start the VFD. So this is that part. Now the last part is actually I forgot to add over here the reference speed through Modbus, through Modbus RTU. Now many times since we are already connected the Modbus cable to the to this 1 and 2 in X2D, and it's already connected to the PLC, we can also control the reference speed to reference speed or reference hertz, depending on your DTC or scalar, directly through the Modbus also. So what parameters we need to look into? Let's jump into that. Wiring wise, we have already done the, let's say, the Modbus wiring. So if the motor control mode is DTC, that is 99.4 is in DTC, then we have to change parameter 22.11 speed reference 1 source is equal to EFP reference 1. That means we are telling the VFD that look at the embedded field bus. EFB is embedded field bus for reference 1. So let's see this 22.11. So in this case we will have embedded field bus reference 1. So this is what we have to check or put. If the motor control mode is in scalar, then we have to put in the parameter 28.11 as frequency reference 1 source is equal to embedded field bus reference 1. And let's see that one, 28.11, it will be embedded field bus reference 1. And this we have to, like, PLC has to write the reference speed or reference frequency into the holding register 40,002. So this kind of covers the, like, you know, the how to do the wiring and parameter changes. I have not covered everything